All right, so this question I'm about to do here involves integration using substitution. So I'm going to look at the question first. I want to take the integral of x cubed over x squared plus 1. So we do have less terms on the top than we do on the bottom, so we can't split up this quotient very easily. However, substitution deems very useful. So I'm going to let u, which is our variable that we always use for substitution, be equal to x squared plus 1. Okay, once you know what you want for u, you're going to take the derivative of both sides now with respect to x. So on this side I have du dx is equal to 2x. Okay, now we want to solve for dx. So I'm going to bring the dx over. So I have du is equal to 2x times dx. Therefore, dx is equal to du over 2x. Okay, let's go back to the original question here. Let's substitute what we have so far. So I have the integral of x cubed, which I will leave the same for now. X squared plus 1 has a new expression, which is just u. Okay, and we're going to multiply by dx, which also has a new expression, which is du, right down here, du over 2x. Okay, so from here you want to clean this up a little bit. You'll notice right away here that we do have an x on the bottom that could cancel out with one x on the top, so that leaves an x squared on the top here. So I have x squared on the top, u times du over 2. Now this 2 right here, that's just a number. That's actually a half if you think about it. So I can take the half out. So I have a half integral of x squared over u, and I'm integrating with respect to u. All right, so you're going to look at it from this stage. You're going to be like, I can't cancel any x's out because there's nothing to cancel it out with. However, we do have a way to rewrite this x squared in terms of u, and that's actually going to come from the original substitution we did earlier. Okay, so as you notice, there is an x squared in here. So therefore, x squared is equal to 1, u minus 1. So if I bring the 1 over, I get x squared is equal to u minus 1. So I can put that into my my integration here. So 1/2 stays out front. X squared is now u minus 1. And we still have that u on the bottom, and of course we're integrating with respect to u. So from here, you'll notice that we have more terms on the top than we do on the bottom, so now I can split up this quotient. So I have the integral of u over u minus 1 over u. And of course, we have the du that follows. Okay, so far, I wouldn't take the integral just yet because we can simplify even further. So u over u gives you 1. Minus 1 over u, that can just stay the same. All right. So let's look at it here. I think we can go ahead and take the integrals. So we have 1/2 stays out front. Integral sign can go away now. Excuse me. Let me erase this. Okay. So the integral of 1 with respect to u is now u. Okay, the integral of 1 over u gives you the ln of the absolute value of u. Okay, and of course we always have to add the constant. Okay, so from here you're going to go ahead and back substitute whatever u was in the first place. And remember, u was up here, x squared plus 1. So I have 1/2 sits out front. I have x squared plus 1 for u minus the ln of the absolute value of x squared plus 1 plus c. All right, so this half is just staying out front here, and I'm going to go ahead and expand that. So I'm going to show you the expansion. 1, 2, 3, actually 4 terms. All right, so we have 1/2 times x squared plus 1/2 minus the half times the ln of the absolute value of x squared plus 1 plus 1/2 times c. All right, so I know this looks a little funny because of our halves here. Okay, so I'm going to point something out to you here. We do have some constants here. 1/2, that is a constant, and 1/2 times c, that is also a constant. When you put these two together, you're still going to get a constant. Okay, so our final expression is going to look like this. 1/2 x squared minus 1/2 times the ln of the absolute value of x squared plus 1, okay, plus c. Okay, so these were combined together to give us just a general constant. All right, so here's my final answer, and I'll circle that for you. And that's how you do this question.